In this video, we're gonna try to find the values of x that will make this inequality true. So notice here we have this double absolute value. So it's the absolute value of x minus 2 bigger than 3. Okay? There are many ways to solve this one here. But for us, we can use some simple algebra too and graphing to deduce the result that we need. First, we need to graph the absolute value of x. So we know this. This is the graph of the absolute value of x. The absolute value of x minus 2 is just the absolute value of x shifted 2 units down. Okay, so let me do it nicely here. I'm gonna do this. Okay, here and here. Okay. So this is the absolute value of x minus 2. But I need the absolute value of x. So the absolute value of x is gonna shift the negative part, which is in this interval, minus 2 to back. So I'm gonna shift it here. Okay, and therefore my graph, let me do it in red. My graph here, let me put this one, and this one. Okay, I'm doing my best to make it look exactly the way I want it. So this is the absolute value, x minus 2. So this is the graph. Let's call it g of x. So this is the graph. So now this value, I know this value. When x is 2, I have 0, the absolute value of 0 minus 2. The absolute value minus 2 is 2. So this is 2. This one is 3 here. So now I want to think of this 3 as a function. Okay? Okay? So here. Okay? So now I can solve x minus 2 equals 3. Okay? And 3 is positive. I can think of it this way here. I can solve only x minus 2 equals 3. And I get x, the absolute value of x is 5. That means x is 5 or minus 5. So here, this is 5. This is minus 5. So the values that will make this one bigger than 3 is when x is in this interval. Okay? 5 plus infinity, and in this interval, minus infinity minus 5. Okay, so the solutions are in minus infinity minus 5 union 5 plus infinity. When I'm in this interval, minus 5, 5, the absolute value of x, the absolute value of x minus 2 is less than 3. We can see it graphically here. Okay, check any value here, it's less than 3. Okay, so it's less, so it's under 3. So this is graphically speaking. So this is the graphical solution for this inequality. But what about algebraic solution? Can we do that? Yes, we can do that. Okay, we need to remember that the absolute value of x is x when x is positive and minus x when x is negative. That's all we need to get our values here. Okay, so let's simplify this expression. Let's simplify g of x. Okay, g of x is the absolute value of x minus 2. Okay, so this one here, so let's call it, I'm gonna say g of x, I mean the absolute value of x minus 2. So this one is x minus 2 when the absolute value of x minus 2 is bigger than 0. Or minus x plus 2 when the absolute value of x minus 2 is less than 0, according to this definition here. Okay? This one will give me what? Let me simplify it one more time. G of x will be the absolute value of x minus 2 when x is in, so the absolute value of x bigger than 2. Let's redraw the absolute value. So this is 1, this is 2. So when the absolute value of x is bigger than 2, so when x is in this interval or in this interval, that means x is in minus infinity minus 2 union 2 plus infinity, and it's minus the absolute value of x plus 2 when x is in here minus 2 2. Okay, now I'm gonna simplify this one. Okay, so let me write g of x again. So it's x minus 2 when x is positive and x is in this interval minus infinity minus 2 union 2 plus infinity. Okay, and it's minus x minus 2 when x is negative and x is in this interval minus infinity minus 2 union 2 plus infinity. And also here, now I'm going to use it here. So this is minus x plus 2 when x is positive and x is minus 2 2. And this is also x plus 2 when x is negative and x is in minus 2 2. Okay, this one will give me some simplifications. Okay, so here, so x is positive and x in here. That means what? That means x, this one, x is in 2 plus infinity. Just intersect these two intervals. In here, x is in here, x in minus, so for this part, x is in minus infinity minus 2. We can intersect these two intervals. And in here, okay, x is positive and x is minus 2 2. That means in this case x is in 0 2. In this case x is negative and x is in minus 2 2. That means x is in minus 2 0. So we have three cases. Okay, if we can throw here these functions given these domains, okay, we're gonna get these values. So when x is bigger than 2, we have this graph, x plus 2. When x is between 0 and 2, we get x between 0 and 2, we get minus x plus 2. Okay, when x is between minus 2 0, we get x plus 2. When x is in minus infinity minus 2, we get minus x minus 2. And based on each of these intervals, we can start solving. Okay, so let me remove here. Okay, in this case, I have this one. Okay, so I'm trying to solve this equation. Okay, so now this is equivalent to x minus 2 bigger than 3 when x is in 2 plus infinity. And I solve here, I get x is bigger than 5 and x is in 2 plus infinity. That means x is in 5 plus infinity. Okay, and I can solve the other cases in the same manner, and I will get the same result that I get when I solve it graphically. I get this one here. Okay, so now when x is in minus infinity minus 2, I get the absolute value is equal x minus 2 is bigger than 3 and x is minus infinity minus 2. So here I have minus x is bigger than 5. That means x is less than minus 5. And x is in minus infinity minus 2. That means x is in here. Minus infinity minus 5. Okay? And in the same manner, I can proceed to see that this one is true only when x is in this interval. Minus infinity minus 5 union 5 plus infinity. Check by yourself to see that the other two cases, one have this line and this line, we will not exceed 3. Check it here. So given this condition, these values, okay, and try to solve, and you will see that you will never exceed 3. That means the only values when we exceed 3 is when we are in here. And this is the interval solution for our inequality x, the absolute value x minus 2 is bigger than 3. Okay, this will end the video.